Alright, so today it's 16.3. This is sector area. So a sector is a region of a circle bounded by two radii and their intercepted arc. So here's an example of a sector. You can see it's the shaded part, right? Here's my two radii. That means I go from the center of my circle to an end of the outside of the circle. Okay, and that shaded area in between is considered the sector. Okay? Now to find the area of a sector with a central angle of m degrees of a circle with a radius r is given by the expression, and I'm going to rewrite it over here. So area is equal to m over 360 times pi r squared. And just to label it, remember r is the radius, m is my angle measure. Both 360 and pi are both constants, so they are always going to be there. Okay, and just to make sure, we already know that A is area. Okay, so we're going to go ahead and just do an example already. It's not too difficult to do. It's pretty much just using the formula. So my step one is going to be replace the values. So remember that my formula is A is equal to the measure over 360 times pi r squared. So the first thing I'm going to do is I'm going to replace m with 210. So 210 over 360, okay, times pi times the radius, which if I look very carefully right here is 3 inches, so 3 squared. And now I'm just going to go ahead and solve. So I can simplify. If I eliminate my zeros there, 21 and 36 can both be simplified by 3, which 21 divided by 3 gives me 7, and 36 divided by 3 is 12, times 9 pi, right? 3 squared is 9, so what I kind of want to do in this case, actually I should have done it in green. Green is to solve. What I kind of want to do in this case is once I have my information, right, 7 over 12 times 9 pi, I kind of want to leave pi at the end, okay? Pi is something that I can kind of push off to the side, and usually because a lot of the questions say round to the nearest tenth or round to the nearest hundredth, it's very common to leave pi until the end because it is a irrational number. It continues forever. So you don't want to just round pi unless they tell me use 3.114. Okay? Now, what I'm going to do is then just multiply this 7 over 12 by 9, meaning I just multiply 7 times 9, which is going to give me a 63 over 12, which I can also simplify, right? I can go ahead and divide, I believe, both of these by 3, and that's going to give me 21 over 4 pi. Now here is where I'm going to want to multiply by pi. But the first thing I'm going to do is 21 divided by 4. Okay, that's going to give me 5.25 pi. And now I'm going to multiply this by pi. Okay, so if I did on my calculator 3.14, I end up with 16.485, which will round to 16.49 inches squared. Remember, my radius was inches, so area is always with a linear unit, so it has to be inches, feet, something like that. so it'll be inches squared. Now, there are two options for calculating with pi. You can try the 3.14, but your scientific calculator does have a pi button. So once you got to that 5.25, you could have just multiplied it by the pi button, and it would have given you something a bit longer, but it still rounds to 16.49, okay? So that's pretty much it. It's only 2 steps in this, using the formula given a sector. Now we're going to go ahead and, I've noticed when your book says applying the formula, it usually means that there is a word problem. So we're now going to use it in a word problem. So I'm going to switch over to my highlighter because I want to make sure that I take note of certain key words in my word problem. So the first thing is, a beam from a lighthouse is visible for a distance of 3 meters. I'm going to highlight my 3 meters, okay? To the nearest square mile, what is the area? So I'm looking for the area covered by the beam as it sweeps in an arc of 150 degrees. So this is basically telling me, and you know, I can figure this out from the section that we're on, but I am going to use the arc formula, this area for the arc, which is m over 360 times 2 pi r squared. Oh no, not 2 pi r, just pi r squared. Okay, so my first step, once again, replace values. So my area is equal to, well, the only degrees that I have, the only kind of measurement I have is 150, right? So it's going to be 150 over 360 times pi, and now my only other measurement I'm given is 3 miles. So that 3 miles acts as my radius. So once again, 3 squared. Now I'm going to go ahead and solve now. Once again, I can kind of eliminate my zeros there. 15 and 36, well, both of these are divisible by 3. So now I can say 15 divided by 3 is going to give me 5, and 36 divided by 3 is 12. Okay, so now I'm at 5 over 12 times, again, 9 pi. It's a weird looking pi. 9 pi. Okay? So once I have that, I'm doing the exact same steps. I'm multiplying 5 times 9, which is going to give me 45 over 12 times pi. Once again, I can simplify this by dividing both of these by 3. And 45 divided by 3 is going to give me 15 over 4 times pi. Now, I could have left it as 45 divided by 12. It's going to be the same thing. But it's just another way to write it, okay? But 15 divided by 4 is equal to 3.75 pi. And now I'm going to go ahead and multiply that by pi. And I'm going to end up with, so it's 11.7. Now it says to the nearest square mile. So when it says to the nearest square mile, I'm not rounding to a decimal, I'm actually rounding to a whole number. So 375 times pi is actually going to give me 11.7, right? So if I'm rounding that, I'm going to have about 12 miles squared. You can kind of see that in the bottom. I'll rewrite it over here. The area is equal to 12 square miles. And that's pretty much it. It's the same 2 steps. I just find my values, plug it in, and solve it, and that's it. So for your practice problems, okay, you're going to have 2 for this section. And you are going to do, let me set up the box. It's going to be in page 878, and it's problems 15 and 18. Those are the only two you have to do for this section. Okay? And that's it.